So this will start a series of training missions for AV8B Harrier for DCS World. So, this is just before start checklist. Let's see how it's going to do.
Welcome to the first training mission for the RASBAM AV8B Harrier night attack aircraft. In this tutorial, we will go through the before engine start checklist, explaining the main functions of the systems. Throughout the training, you will be required to press spacebar to indicate that you are ready to proceed to the next step. The instructions will be visible on the screen until you do so. You can take as much time as you want at each phase. Let me know when you're ready to begin. The AV8B Harrier night attack aircraft is a transonic, day and night tactical ground attack fighter built by McDonnell Douglas Aerospace. It entered service with the United States Marine Corps in 1991 and is still in service today. The Harrier features high shoulder-mounted swept wings with leading-edge root extensions, or lurks, and automatic maneuvering flaps that aid maneuverability at high angles of attack. The aircraft has overall positive dihedral, aerodynamic, and high lift characteristics, enabling it to carry a deadly array of general-purpose and precision-guided munitions on its 7 external stations. The Harrier has 7 internal fuel tanks with a capacity of 7,759 pounds of fuel, and its range and endurance can be increased with the addition of up to 4 external wing tanks and/or the use of probe and drogue aerial refueling. The aircraft is powered by a Rolls-Royce F402 RR408B Pegasus non-afterburning turbofan engine that provides 22,200 pounds of dry thrust. The F402 engine also has thrust vectoring exhaust nozzles that enable the aircraft to perform its signature vertical or short takeoffs and landings at sea or forward bases close to the front lines. A water injection system used for heavy VSTOL operations lowers the jet pipe temperature and increases the thrust, for a short period of time, to up to 23,400 pounds. Flight controls are hydraulically powered to provide the desired effects throughout the Harrier's speed range, and a reaction control system, or RCS, diverts engine bleed air through the nose, wing, and aft puffer vents for attitude authority in jet-borne flight. The cockpit is divided into 3 major areas. The left console, from aft to fore, contains the oxygen monitor panel, fuel shutoff handle, pilot services panel, external lights panel, exterior lights master switch, fuel panel, throttle quadrant, stability augmentation attitude hold system, or SAS, and trim panel. The main instrument panel, looking from left to right, contains the landing gear flaps control panel, the combat water panel, the armament control panel, the master armament panel, the left and right multi-purpose color displays, the option display unit, ODU, the heads-up display, HUD, the upfront control, UFC, and HUD control panel, standby flight instruments and indicators, the FLIR power panel, miscellaneous power switch, the circuit breaker panel, the warning lights panel, the engine display panel, the fuel quantity indicator, the electronic countermeasures or ECM panel, the clock, and the brake and hydraulic pressure indicators. The right console, from fore to aft, contains the electrical panel, the VHF-UHF radio set control, the auxiliary communication navigation identification panel, or ACNIP, the interior lights control panel, the environmental control panel, the NVG stowage compartment and video recorder, and the ground power panel. The aircraft should be pre-configured by the plane captain prior to entering the cockpit, but it is important to conduct your own pre-start checks. These checks are performed in a left-to-right flow, beginning with the DCS enable switch. DCS enable switch should be set to off. DCS stands for Digital Engine Control System and is responsible for proper functioning of the engine. Make sure that the fuel shutoff handle is also set to off at this stage. In this position, the fuel system is completely isolated from the engine. Move forward to the pilot services panel and verify that the engine RPM select switch is set to low, indicating the low pressure fan RPM on the engine display panel. Selecting high displays the high pressure compressor RPM. Now set the engine fuel control or EFC switch to position 2. This switch determines which digital engine control unit, or DECU, will control the fuel metering unit responsible for the correct fuel flow into the engine. Next step is to verify that the Lift Improvement Device System, or LIDS, is in norm position. LIDS is a retractable fence that, when deployed, increases the vertical lift by directing the hot jet stream energy. It is part of your landing gear system. Good. Now check that the oxygen switch is set to off. This switch controls the operation of OBOGs, or Onboard Oxygen Generating System. Let's move to the H2O dump switch and make sure it is set to off. As the name implies, you'll want to use it to empty the 500-pound tank of distilled demineralized water. Water injection allows you to temporarily increase the engine RPM during takeoffs and landings. Moving to the external lights panel, ensure the formation, position, anti-collision, and auxiliary landing light switches are set to off.
Off. Everything is off.
Verify that the air refueling switch is in the in position. This pressurizes the fuel transfer system, transferring fuel to each center tank in series from all tanks in the group at the same rate that the fuel is being consumed from each group.
Here is.
The left and right dump switches should be set to norm. This powers the left and right fuel jettison valve motors. Now ensure the left and right pump switches are set to norm. These energize the left and right AC boost pump relays located in the lower portion of each center feed tank. Check that the fuel flow proportioner is set to on. This powers the fuel flow proportioner, ensuring equalized flow of fuel to the engine between the Harrier's two feed groups. Next, ensure the throttle is fully aft in the off or idle cutoff position.
So, how do you make sure is in the idle cutoff?
Verify that the jet pipe temperature limiter is set to on. This ensures that the deck's JPT limiter function is not muted. The JPT limiter uses thermocouples and the turbine exhaust sample gas temperature to limit the RPM in different configurations. Now ensure that the manual fuel switch is set to off. The manual fuel system provides an alternate means of control if the primary fuel control system fails. It directly controls engine RPM and contains no automatic compensation, controls, or limiters. In the off position, engine control is performed by the decks.
It is.
Ensure the parking brake is aft in the on position. The parking brake applies approximately 3 hours of brake pressure in the system and prevents the throttle lever from moving past it while the lock is engaged.
Good to go.
On the stability augmentation and attitude hold system panel, set the pitch, roll, and yaw stability augmentation system switches to on.
They are on.
Set Q-Feel to the on or Q-Feel position. Q-Feel provides artificial longitudinal force feedback due to the primary flight controls being entirely hydraulically powered. Set Alt Hold and AFC switches to off. This disables both altitude hold and automatic flight control modes, which will be covered in a later lesson. Set the rudder pedal shaker yaw switch to on. Rudder pedal shakers give an early warning of side slip at low speeds. The shaking pedal should be pushed to counteract the side slip. Set the landing light switch to off. There are two landing lights, a 250-watt filament for landing approaches and a 150-watt filament for hovering. Next, move to the landing gear flaps control panel and set the anti-skid switch to on. Anti-skid controls hydraulic pressure to the brakes and prevents skids above 16 knots and partial skid protection between 16 and 8 knots. Note that the anti-skid is inoperative while the parking brake is engaged. Check that the landing gear handle is in the down position. Check that there is no white band showing at the base of the landing gear emergency battery handle, which would indicate that the battery has been previously fired. Next, verify the flaps switches are set to auto and off. Off disables power to the flaps mode switch, and auto provides 25-degree flaps with the landing gear handle in the down position. At the lower left of the main instrument panel, ensure the water switch, labeled H2O, is in the center off position. This prevents water from being injected into the engine. Verify that the master arm switch is off. On the Armament Stores Management Control Indicator, ASMCI, verify that the selective jettison knob is set to safe, and the manual release control knob is set to norm. Safe prevents selective jettison of stores and suspension equipment. Verify the IR cool switch is off. IR cool begins cooling infrared sensors and stores. Ensure the multi-purpose color display, MPCD, is off. The MPCDs, often referred to as the digital display indicators or DDIs, are 5x5-inch CRT displays surrounded by 20 multifunction push buttons. These push buttons are numbered 1 through 20, beginning with the bottom button on the left side of the panel and counting upward in a clockwise direction. They are turned on and off with the brightness knobs located directly above them. Set the head-up display or HUD brightness knob as desired. The HUD is the primary attitude indicator, weapon status, and weapon delivery display. It displays collimated symbology and is electrically interfaced with the upfront control and HUD camera.
Done.
Set COM1 and COM2 volume by rotating the knobs to the 12 o'clock position and adjusting as necessary.
Turning the knobs to 12 o'clock position and adjusting as necessary. Whatever.
Set UFC brightness as desired. Verify the clock is set to the proper local time.
Yeah, whatever.
Next, bring your attention to the miscellaneous control panel. This may be
Another
obscured
one.
behind the stick. Verify the FLIR switch is set as desired for the mission. For now, leave this switch in the off position.
Off.
Set the video recording system, or VRS, switches to the auto and HUD positions. Auto mode commands the mission computer to turn on the video recorder when air-to-air, AA, or air-to-ground, AG master modes are selected. HUD records the HUD camera. Set the dual mode tracker, DMT switch as desired for the mission. The DMT allows the pilot to track a pixel contrast TV image, or coded laser energy, for target acquisition and attack runs. For now, we can leave the switch in the off position. Verify that the Inertial Navigation System, or INS mode selector knob is in the off position. The INS is coupled with the aircraft's GPS to provide accurate aircraft and targeting system coordinates for navigation and attack. The INS will be covered in more detail in a later tutorial. Ensure that the display computer, or DP switch, remains in the auto position. This switch controls selection of redundant display channels that drive the HUD and DDI. Auto is the default mode. Next, ensure that the mission computer, or MC switch, is also in the auto position. In the event of a mission computer failure, auto will allow the display computer to be used as an emergency backup. Finally, verify that the probe heat, PRB, switch is set to auto. This switch energizes the various probe sensors on the aircraft, and auto mode removes power from all heaters except the angle of attack case heater with weight on wheels. Once airborne, all probes will receive heat. Below the miscellaneous switch panel, verify that all circuit breakers are in the in positions. There are 7 circuit breakers controlling aileron trim, stabilator trim, rudder servo, flaps, speed brake, landing gear, and the right probe heat.
I cannot operate them, so I suppose.
Now draw your attention to the electronic countermeasures panel on the right front dash. These switches control radar warning receiver, expendable modes, and electronic countermeasures, and will be covered in detail in a later lesson. For now, leave these switches in the off position. Let's move on to the right console now. On the electrical panel, verify that the battery switch is set to off. The battery switch powers the ground service, switched battery, jettison, alert, and emergency 28-volt DC buses with generators and transformer rectifiers offline. Set the generator switch to Gen. The main generator is an engine-driven 30,000 volt ampere variable speed constant frequency generator which provides 115/200 volt 3-phase 400 Hz AC current to the aircraft main and essential AC buses and to both the main and standby transformer rectifier units, or TRUs. In this setting, the aircraft generator will automatically come online when the engine reaches approximately 23% RPM. Failure to set this switch may result in a dual DEX failure during engine start.
Okay.
Next, set the VHF/UHF radio remote control on the Auxiliary Communication, Navigation, Identification Panel, or ACNIP, to transmit/receive, or TR. Configure the rest of the ACNIP to suit your assigned mission. At a minimum, verify that the mode switch is set to the upfront control, or UFC, to set primary control of your ARC-210 radios to the UFC, and verify that the identification friend or foe switches are set to norm. On the internal lights panel, set the compass, instrument console, flood, and warning caution lights knobs as desired to suit the environmental conditions. Now, on the environmental control, or ECS panel, set the temperature controller to auto. This electronically regulates the cabin temperature. Verify the equipment bay cool switch is set to on. This sends bleed air through a ram air-cooled heat exchanger to the aft equipment bay housing most of the aircraft's avionics equipment. Verify the defog switch is in the norm position. This diverts a portion of the cockpit airflow away from the pilot to the windshield defog ducts. Finally, verify that the cabin pressure switch is also in the norm position. This opens the cabin pressure regulator and discharge valve on the forward cabin bulkhead, maintaining a constant cockpit pressure altitude of 8,000 feet. At altitudes between 8,000 and 23,000 feet, and a constant 5 psi pressure differential greater than ambient pressure above 23,000 feet. That covers the after entering cockpit checklist and cockpit familiarization tutorial. You may now continue to the cold start part of the training.
Cool. Okay, so this part is not really bad at all. I mean, it's quite cool. A lot of explanations of what does what in the cockpit, which is very cool. The problems I had were with the throttle, so I had to map the lock of the throttle to cut-off position. So for example, let me remove the parking brake again. I have a switch assigned to my cockpit to remove the parking brake, and now the throttle works all the way. However, to put it back, it's very difficult to click on this spot. So let's see if I... No, this one just removes it. Yeah. So the throttle has to also move. And yeah, it doesn't work really well. But will do. I mean, it's the list of the problems. Basically, I have a cutoff on my throttle that does exactly this, what it's supposed to do. And it does. But I wish the clicking procedure would work the same way. But it doesn't. So, yeah, no worries. So basically, you see, I can click, but the throttle doesn't move. Well, I guess it will work anyway. In VR, because the whole series will be recorded in VR, the pilot body is not actually interfering at all with buttons. I can see my console here. I can see the buttons. If I lean forward, even if I don't lean, the only cover that is really, the only switch that is really covered is the INS, which is basically operated just once. And also there are some switches here on this side that can be covered by my left hand, but the body can be toggled, and also these switches are used usually only during the startup. And in air-to-air refueling mode, basically I should have a switch assigned to my HOTAS or to the cockpit. So no problem. The body is very well animated. Even the legs are moving when I hit my stick with I hit my legs with the stick. The body is proportional, however, I feel very skinny. Like the hand is where I feel. So let's see. So my hand is there. Yeah, so it's a bit on the back, but on the back side the hand, but not really as bad. You don't really notice in VR that the hand is actually forward. Basically, when I saw it now, I was a bit surprised that the hand was actually further back. The cockpit hand, the virtual cockpit hand, compared with my real hand. So let's see now with the stick. So also the stick is forward, but again, I don't really feel it. It's fine. My knees, let's see. So also my knees are further in. Again, I don't really feel it. I don't think the cockpit would be bigger in real life or felt as bigger. It's proportional. It's very fine. The graphics are almost great. The module is a bit old now, but still in VR holds together okay. When you go close like this, you start to see that the cockpit is actually made of polygons covered with textures. Which is something you start not to notice in, for example, titles like Microsoft Flight Simulator 2024 in some of the new cockpits. But it's acceptable. So this will conclude the first lesson. We'll see the rest of them.